Hello everyone, we are the team BEST and I am Ezgi from the Mechatronics Engineering. In the previous presentation, we have mentioned that our problem was stroke because it was the second leading cause of death in the world. So we want to predict potential patients who are likely to get stroke. And the data set we found was supervised and classification data set. And now Furkan will remind you our data set.
Furkan sesin kapalı hocam.
Sorry. Hello everyone, I'm Sam Furkan Yıldırım from Mechatronic Engineering. I'm going to talk about our dataset. We have found stroke predict dataset on Kaggle. We have 5,110 samples and 11 features. These features are gender, age, hypertension, heart disease, ever married, work type, resistance type, average glucose level in blood, body mass index, smoking status, and stroke. In this dataset, we have some missing data on body mass index and smoking status. Now, Berke will explain how we corrected the missing data.
Hi everyone, my name is Berke Uysal from Computer Engineering. What we did to solve this missing data issue is that we used the impute function that is present in the Orange application, and we used the model-based imputer option to solve this issue. And what model-based imputer does is that it takes the value from the most similar example and puts its value to the place of the missing value data. And our in our data set, 3% of our data was missing, and after this function, none of them were missing because they were filled by this function. And now I will show some data and graphs. In this scatter plot graph, you can see that average glucose level and BMI distribution. And a blood sugar level less than 140 is normal. And blood sugar level that is greater than 200 indicates diabetes. So these people have diabetes, and these were the normal blood sugar level people. And this is its distribution. And this plot shows the age and body mass index. As you can see, as people grow older, their risk of getting a heart disease and having a stroke increases rapidly. Now my friend Typhoon will tell you about the distribution graphs.
Hello everyone, it's Typhoon from Information Systems Engineering. And as you see, I will continue in distribution graphs. This graph is a heart disease and stroke info about our data set. Can we continue? Yeah, another distribution graph is in hypertension and stroke info. As you see, we can see the details, and we can see the percentages of the in-group and overall data. And another one is marriage data and stroke info. I think we forget the other data. Okay. And distribution graph of work type and stroke info, and we can see here. And this one is residence type and stroke infos, urban and rural. And as my friends and I said, if we get the percentages of this data, we can easily get the results, and analyzing this data can prevent to such a dangerous and deadly disease like stroke and heart attack. And if we work on this data set, we can predict whether a patient is likely to have a stroke. And for the prevent from a stroke and a heart attack, we can easily see some factors, stroke, and as you see, some of that like various variables cause a heart attack, and the higher people over the age 50 may more likely to have a stroke. And as you see, only enough marriage is a big factor in a heart attack. And also this is why some of results of our data set. And thank you for all listening to us. And if you have a question, we are ready for answer.
Questions? Did you check the correlation values for this sample?
Yes. didn't we?
So what do they tell about? So is there any high or too low values for that?
Actually, we have age in this part. There are more sample than above 80 or something age. So it was, but we realized that there are more people, there are many people below the age of 80. So it wasn't that problem for us, actually.
Okay, thank you.
Do you think that you are going to add a new feature?
No. I don't think we need that, because if we add more feature, it will be more likely to overfit, I think, because we have not that much, that many samples, so it won't be suitable for that, I think.
Thank you.
I'll have a question, but you kind of answered it. Do you think 5,000 or how many data samples you have will be enough for this project?
Actually, we are not sure about that too, but in the previous presentation, we haven't any feedback for that. So we thought it was okay. I don't know if it's okay. Is it okay, sir? Is it too low?
I keep myself. Okay. Any more questions?
Can I ask one?
Yes.
For missing data, you said that you used model-based imputer. Is it making correct guesses? Will it impact the total accuracy of your models?
Actually, it does. Berke, you can answer that. You are the one fan.
It actually puts into place the closest value. It finds the most similar example with the similar heart disease or similar glucose level, average glucose level, and it puts its data in its place. So it is the closest way we can fill these values, because that our data set is 5,000. We didn't want to remove any instances of data, because 1,500 values of smoking was missing, and if we remove that, there was no data left for us to play with. So we use this function to solve this problem.
Thank you.
As I said that I am recording these questions and giving bonuses for the who asked the question. Okay, so already I am noting down. Okay, so please pay attention that I am giving bonus for these questions. So Sami, Furkan,
Yes.
you just showed us in 2 or 3 slides ago some distributions or the graphs. Yes. For example, this one. Why did you provide these graphs to us?
Because we think that hypertension, how much it affects on stroke.
Can we see this?
Yes. Red ones are strokes, actually.
Okay.
Blue ones, not strokes.
Okay.
So we see that hypertension is how much affect this.
So how much?
Actually, 10% people of this has hypertension. And 90% of these peoples have not hypertension. In the have not hypertension peoples are wait a minute, nearly 4%. of these people has stroke, get stroke?
Sami, do you think that we use the distribution graphs to understand how much they affect the target value?
I think yes.
Or the correlations gives us?
Can I answer that?
Just a moment, let's Furkan things.
Okay.
So by the way, if you go to the previous slides, go to previous. Okay, you don't have. In our other presentations, you notice that they provided the correlations, right? The correlation graphs, the plots, right? You don't have. In that plots, we can see the correlations. Remember that, find the most related features. Remember that? Useful features. In that features we provide, right? Sami?
Yes.
So you need to use the Pearson correlation in previous slides. The people show the correlation. So if you are looking for the relationship between the feature and the target value, you need to look at the correlation, not the distribution. The distribution is for something different. Distribution of the data, right? So it means that the values are shown here. And the second question for you, Sami. So when you look at this scatter plot, what you suggest us? Do you think that average glucose level and body mass index, if you look only these two features, what can you comment on this graph?
I think red ones are get stroke, blue ones are not. So on average glucose level, under the 120, people get more stroke, and under the nearly 119.
How do you understand? Excuse me, Sami. How do you understand that 120 less?
I talk about average glucose level.
But I think that they are all equal, above and lower. Look at the number of the reds.
Yes.
I think the number of reds almost equal. Anybody has idea, Ezgi?
Sorry, actually, the normal level of glucose is the 140. So if it's too low and if it's too high, there are more likely to get stroke.
No, what I am saying that if you put something like that here, everybody sees what I am drawing?
Yes.
Yeah.
So what I am saying that the number of the reds, the number of the reds and the number of the reds looks like similar, right?
Yes.
So they are evenly distributed. Am I right? Evenly. So by using this feature, you cannot tell much thing, but you might, maybe you might tell that maybe in between this region, we have less number of heart attacks. Is that? Yes, stroke, right?
Yes.
So Sami, so it's not a good point, and you need to have some data to tell this, but only looking this, and for that feature, this was BMI, yes, and similar thing for BMI, everybody sees that. So if you consider the BMI values between 20 and this, I don't know, 50, it doesn't tell you anything, right? Because everyone is there, heart stroke and not heart stroke, right? So according to this table of graph or plot graph, I would say that maybe these two features are useless. Am I right, Ezgi?
Yes.
Only considering only these two features, only these features, not thinking about the relationship with other features, but this. Typhoon?
Yeah.
I mean, we just want to show that the normal data, the normal level of the glucose level should be there, and if it's high or low, yeah, it should be stroke. But you're right, we need more. We can manage the body mass index.
What I am trying to show you is that only giving the plots, graphs is useless. You don't know anything.
Yeah.
I don't learn anything from you. So you don't learn anything from data. You are just giving some scatter plots and you can create hundreds of it. But so what? What you are gonna with these features? Are you gonna use it? Are you gonna transform it? Are you gonna delete it? Sami? Sami?
Can you ask?
So
two
what you are gonna
questions?
do with these two features after looking this plot graph? Or just next slide or the previous slide, anyone, please. What you are gonna do with that one? What's your comment on the features? Why did you provide these graphs? What we are gonna do after that? What we are gonna do some updates or changes in my data set? Why I'm looking this graph? What's the purpose?
I think we not correctly do something. I understand that.
So just copy and paste the graphs is not enough. Do you understand? You have to
Yes.
purpose, then you have to comment on it, then you have to take some actions on your data set. Not for each graph, but some graphs are just graph, but some graphs tells you something, then you need to check the others. For example, as mentioned, maybe you need to check the mean value, right? And there is the feature distributions widget, right? Features widget in the orange, and it gives you some dispense and the other informations, average, right? And you need to think of, so you try to put something, but randomly selecting some scatter plots is not good because you might have hundreds of features. You cannot put, and after putting these graphs, you need to be commenting on it and take some actions for your data set. So this, you need to work on your data set more. Do you understand me?
Yes.
Yeah.
It's not enough. Okay. Thank you for the presentation. We can move on with the next.
Thank you.
Thank you, sir.
Thank you.